give you the challenge question.
We want to volunteer number 14, ruler tree.
Number 14. Accept. Okay. So the problem is number 14, ruler tree. So the presenters, please come to the blackboard, write down your name. So reporter, you have 5 minutes to prepare. go ahead.
Hello everyone, my name is Jason Yang, and reporting the ruler sheet. This is the problem. Place the ruler on the edge of the table and draw a ball at the end. Ruler will fall. However, if you cover a part of the ruler with a piece of paper and repeat the throw, then the ruler will remain on the table while the ball will bounce off it. So we need to explain this phenomenon and investigate the relevant cases. This video shows that by placing the paper on the ruler will remain. But if there's not, the ruler will just fall if it gets hit. And since then, we view the ruler itself as a lever, with forces act upon it. One is transmitted by the ball, while the other is caused by the difference in pressure. And also in that since there's a sudden change in volume, and in that direction, the force will stop the ruler or even diverse its rotation. And the main purpose of the research is we want to investigate the height effect. And another is to find the safe range. The ruler won't fall if we release the ball in that range of height. At the same time, we try to include the factors as much as possible. And this is the methods we took. We use the leverage principle and Newton's laws of motion to interpret this phenomenon. And here's the process of calculation. And the red one is the unified equation. They describe the force situation on the ball. And a design we made is a square fixture made of popsicle sticks. It prevents the ball from moving around. And then a person might hold another stick under and get ready to set it free. And next, we use a high-speed camera to record the whole process and then analyze it through tracker. On the other hand, we set a pressure sensor and get the pressure. As for the control variables, the first are the objects themselves, and the next is their relative positions, the arms, for example. And this is what our setup looks like. But the ball and the sensor were not in their positions yet. And you can see there's a pipe there. We'll connect it to the sensor whenever it's needed. And this is the device to sell. It was made by inserting a pipe into the stopper. It can make sure that the air won't rush in. And the procedure of our experiment can be divided into three parts. The measurement, collection, calculation. The measurement is about how long is something, or are they at a right angle. And collection is about getting the pressure under the paper. And we calculate the results finally with our formulas. And this is how we get to know the duration. There's a timestamp down there. For example, I think the time there is accurate enough. So the duration would be the final and the initial time, the difference between them. And this is how we get the average pressure during a period of time. It equals to the average of the maximum and the minimum. And in this situation, the maximum is the normal pressure. And to put it simply, the higher the height, the more the pressure decreases. And these are duration and velocity change. They all decreases if we release the ball from a higher height. And actually, I think it is surprising that the velocity change actually decreases if we release the ball from a higher height. And I think the most important part is that we can think of the structure of the acceleration. If the velocity change increases or the duration decreases, the acceleration will increase. But notice that if the duration decreases faster, it also works. And I need to add, in addition, that I need to mention that the bigger the acceleration, the bigger the force. That's why the paper cannot hold on every time. And these are the limitations. The first is that we don't know how to calculate the volume accurately because its shape is somehow complex. And second is that we cannot make sure about the amount of the molecules and its increase while the air flowing in. And the last is the bending moment. It involves elastic mechanics, but I think it will be too complex and sophisticated, so we didn't include it. And so we investigated the phenomenon through classic mechanics. And we discovered the relation between the height and the change of pressure, duration, and velocity. Even though I don't know how to predict the results with our theory, but it does correspond, and we can tell that from the chart. So I think it supports the theory. And that's all. Thank you for listening. Thank you. Okay.
So question from the opponent?
I would like to ask, did you put the ruler in the middle of the critical experiment?
You mean which part of the ruler?
Like the and
Yeah.
do you make sure the ruler is in the middle or is like left a little bit or right a little?
The both of their position is fixed, so I think.
And then my next question is, you say you use two paddles to make sure the ball isn't moving, and then you put another thing off so the ball will drop.
Yes.
Right. So do you control the ball will drop at the same position, same spot at the ruler every time?
In a certain range, we can control that.
Okay. And do you think the ruler is a rigid body or elastic object? So do you think your ruler is bendable? Can you bend the ruler?
If the force is enough.
Okay. And do you think this phenomenon will still be seen if we put the whole system in a vacuum place, which means if you put the whole thing in the outer space, in the space, do you think it will still happen?
No, it will not because there's almost no air pressure.
Okay. And have you found a limit situation when the ball will fall? Like the limit situation between the ball fall and the ball and the ruler fall and the ruler didn't fall. Do you find a limit between these two?
Yes, if it's high enough, or if you put the ball directly on the ruler, it will fall because the force maintains a certain time and it's long enough the air flows in, so the difference in pressure will vanish, so it also falls.
Sorry. Yeah. So Coleman, you have 3 minutes to prepare.
everyone, my name is S601 PF1. And today I'm going to oppose problem number 14, ruler trick. And here is our problem statement. And to this problem, we are going to mainly focus on the reason of the ruler falling down and torque acting on the ruler. An overview of the report. He talked about Newton's law, Lever's principle, and Boyle's law. And his process, he used Lever's principle and to clearly explain his experiment. But he didn't consider about the friction and resilience of the ruler. And also, he didn't consider atmospheric pressure. And about his experiment and setup, he changed releasing height to find the range which the ruler will not fall in. And his process, he used high-speed camera to get a video, and he considered more he considered more variable. And he didn't consider about the effect of airflow, and he didn't consider the rotation of the ball. And about his data analysis, he talked about which part that the ruler will not fall. He called it the safety part. And he also talked about the variation of the velocity. And his process, he used experimental results stick to the theory. So his theory can explain the experiment result, but he has lack of theoretical line, and he has large error bar. And here is the thing I'm going to discuss about the theory. I'm going to discuss about torque equation and friction between paper and the table, ruler's resilience, and air pressure on the uncovered part of the ruler. And I'm going to talk about if you consider the ruler is elastic or not, and is there other force do on the ruler level change the torque equation, or why only consider air pressure at one side of the ruler and consider air cavity when the collision happens. And about experiment and setup, I'm going to talk about position of the air circulation and releasing method. And I'm going to ask about the accuracy of the releasing method and how the airflow caused the ruler to fall. And for data analysis, I'm going to discuss with him about theoretical line and ruler dropping limits. And I'm going to talk about why he has such a big error bar, and theoretical line didn't fix the experiment, and also didn't find critical condition for the ruler to drop. Thank you. And now I want to invite the recording. So I see that, can you turn to the page to talk about the theory? Okay, so can you kind of like explain the whole thing again? So you use, let me just give this part. And what I'm saying is that the problem statement, it says that maybe the ruler will maintain on the table, or maybe it will fall. So I think this problem, what is really important is the critical condition. And so I think, and do you agree with that, to find the limits whether the ball will fall or not? Do you think that is important?
Yes.
Okay. And I think if I want to find out which part is important, I think maybe we should use torque to explain what this is. Do you agree?
Yes, there's the.
Okay, so because you only write the numbers here, can I ask you to draw a graph to explain what force really due to the ruler and the paper?
Oh.
Okay, so. Okay, so if this is the table, and you put a ruler here, and you cover it with a piece of paper. And can you tell me which force will affect the torque?
It's mainly from the ball, and another is from the central of the paper.
And which is the center of the paper? What is the force?
Because the pressure here declines, so the pressure above the paper is bigger, and since then the resultant force will be downward if we simply consider the paper.
Okay, so do you think there are other forces you should consider about this part?
About gravity.
So you think you have to consider gravity on this part?
Yes, and also, if it's possible, we will talk about the bending moment, because anyway it bends, and another one is maybe the tension of the force.
So you think the fact that the ruler will bend is important?
Yes.
Okay, so although I didn't see it in your experiment, I didn't see it in your presentation, but I think you say before you told me that you think the ruler is elastic, so you can bend the ruler. So I think if we are going to calculate you say the moment when the ruler is bent, right? So let's say when the ruler is bent to this part, then there will be a theta angle here. So we can use the formula. We can use the formula to calculate the force, because after it bends down, it should have a force to give back, to bounce back, right? So I think you can calculate the force by using this formula. And so in this formula, this theta is just the theta angle here, and the D part, D is this part of the ruler. And K is, you say you control the ball to drop at the same spot every time.
Yeah.
Okay, so if you consider to drop it at the same spot, do you put the ball to drop at the edge of the ruler, or you drop it like inside a little?
Inside a little.
Okay, so if you drop it inside a little, maybe you drop it here. So this will have the distance here, if we call it K. So you can calculate the force when the ruler is bounced back by using this formula. Do you agree? Okay. Then also in your short question time, you say that if you put a ball on the ruler for too long, it will also fall. Right. Then can you explain why do you think it will fall?
Do you mean here or above?
You say in your short question time, you say if the ball is on the ruler for a long time,
Yes.
it will still fall.
Yes.
Yeah. And so can you explain, or you can draw, like why will this happen? Like maybe the airflow inside the paper.
It is because that the force constantly exerted on the ruler, and so it provides enough time for the air to flow in, and the pressure above and beneath becomes balanced, and there will not be any force anymore.
So that's what you say. That's why the thing will fall down.
Yes.
Okay, and also in your presentation, I see that you draw an air gap. So that's okay. So I see that you draw an air gap here. So you draw that this is the paper, and then the ruler is right here. So your graph says that the ruler, after the ruler is hit by the ball, it will go up. So it will have. So if this is the ruler and this is the paper, so it will have an air gap here, right? And so I think you say that the time is important. The time that the ball gave the ball to the ruler is important in this question. So I think that the reason why it is important is because how long the air gap is created is really important, because if the air gap has been there for too long, it will be more easy for air to come in. So I think that is also why when the time that the force due to the ruler increase, it will be easier for the ruler to fall. You agree?
Yeah.
Okay. So next part. In your equation, do you consider about the atmospheric pressure?
Yes. No, we only calculate the difference. That means the pressure decreased.
That means the pressure decrease. So you consider about the difference.
Yes, because if the pressure is balanced and it don't influence the system.
Okay. So I think that you should consider about the atmospheric pressure here, and also, and you should consider about atmospheric pressure here. And in my opinion,
You mean under the
no,
paper?
like do on the paper.
Oh.
Yeah, and also because I think that when you put the paper on the ruler, yeah, okay. When you put the paper on the ruler, it will not be really flat. Like the part with the ruler will go up a little bit. So when you calculate the atmospheric pressure, you should have different kind of way to, like maybe this part, this part is the part when the ruler goes up. This part will have an air gap here. So maybe so I think that the air pressure should be only considered on like this side, and this side should be calculated as the other kind, which is the thing that you say you use the pressure difference. So I think this part should use the pressure difference between inside the paper and outside the paper. You use ideal gas equation.
Actually not. It's only in discussion.
Oh, okay. So next part, I want to talk about your data. Okay, so yeah, this one. Can you explain what this chart is talking about?
This is the process that the pressure under the paper decrease and recover again.
Oh, so this is talking about the pressure. Oh, okay.
The x-axis is time.
So this is when the ball drop and the pressure will decrease, and after the ball bounce off, the pressure will increase again. Okay, next chart. Next one. Okay, so I want to ask about you can see that the error bar at every data is really big. Can you explain why?
I don't think it is really big because it is only about 10 milliseconds, or yes.
Okay, so maybe the real number of that is not really big, but because like this data points, the error bar of it will even contain another data point. It's really close. So like I think you need to make your experiment more accurate.
Oh.
Like maybe you need to change your way how to release the ball or to make it more accurate, so the error bar won't be that big. Do you agree? Okay. And okay, thank you.
Your opponent, please summarize your discussion. Opponent, 1 minute.
Thanks to the reporter. In the discussion part, we discussed about how will the talk affect the experiment results. Both of us think the bending of the ruler need to be considered, because if the ruler will be bending, we think it will fall elastic force to affect the experimental results. So we think that we should consider the force of a torque to analyze. A ruler will fall. And then the reporter said that he thinks when we release the ball in low height, the ruler will fall. He said that the reason is because the air pressure in air cavity and atmospheric pressure will be balanced. I think the most important thing he needs to mention is the time the ball affects the ruler. Thank you.
Thank you. So question from the reviewer.
I would like to ask the reporter about what will happen when a ruler barely reaches the boundary condition, which it will overcome the friction and size down.
Can you repeat that?
So how do you take the phenomena when it overcomes the friction and size down? How will you explain that now? There's also one kind of ways that this ruler can fall, it can drop or slice down. How would you explain the action of the ruler slice down?
Oh, do you mean the ruler just move like this?
Yes.
Since its torque is not bigger than the then the torque which is caused by the difference in pressure. So I won't consider it is called fault.
Okay. Then, how do you, like, both reporter and opponent think the area of paper will affect this phenomenon? Like the size of the paper?
Yeah, I think it will affect.
Like how?
Yeah, because when you calculate the torque, you also have to calculate how much air pressure is it to do on the torque. So if the area of the paper is bigger, which means it's increased, then the air pressure will give them more force. So I think it will affect the result.
Thank you. What about reporter?
Yeah, I also think it will affect the result.
Okay, thank you. So, what do you think about angular momentum acting on this phenomenon for reporter?
Which moment?
The angular momentum.
Angular momentum.
Yes. Did you put that into your consideration in your theory?
No.
Okay, so next one, do you investigate the ruler? As you investigate the ruler force or not, how would you define the differences that it actually falls down or not? So since like the previous question that I asked you, the slide down and not, how would you define the fall ruler?
I think a foam ruler must be capable to lift the paper up and then rotate outward.
So if it's not rotating, the slide down, and you were not
Yes, because
that in your experimental data, right?
yes, because sometimes we observe that even the ruler has lifted the paper, but it rebounds.
Okay, so that considered as a successful data inside your experiment.
No, I don't think that is successful.
Okay, thank you.
Thank you. You have 2 minutes to prepare. Okay, hands up. Reviewer.
Honorable judges and worthy debaters, this is Team Me 1 reviewing the problem 14 ruler trick. So, as the problem statement stated, that this problem should ask the reporter to explain the phenomena and investigate the relevant parameters. So the summary of, I will summarize the reporter's points, which they explain the phenomena by the Lagrange principle and Newton's law of motion, and also the Boyle's laws. And he did experiments regarding the heights affecting this phenomena, including the result of as the height increases, the change of pressure will also increase. And also they conclude the reason for this is because of the acceleration, which as the ball increases higher, the acceleration will be greater. And this also leads to another result of the ball falling down, which is the ruler falling down, which is the boundary condition. So the pros and cons, the disadvantages of the reporter's presentation is about it have a really good fading data and have a clear videos showing the phenomena. On the other hand, they lack an explanation of theory and evidence to proven that they have an accurate time measurement. And also the little relationship between the theory and experimental data. So about the opponents, we think that it's really good for them to doubt the accuracy of their dropping experiment, and also detailedly inquiries the condition regarding the boundary condition. And last, they also add reasonable own perspective regarding the friction and elasticity during the discussion. And however, the lack of explanation on the factors in the free body diagram thing on the blackboard. So if they first discuss about boundary condition, which is important or not, and the reporter considered it as really important, and we as a reviewer consider that the length and the width of paper should also put in a consideration of the boundary, for the boundary condition. That next discussion is regarding should the torque be considered into the phenomena, and what is the force that creating the torque into it. So the reporter agrees that there's actually torque acting on the phenomena. However, and the force is because of gravity and bending moment, including that the bending of rulers is actually also significant. And us as a reviewer consider that the torque is also an important element to explain the phenomena. Adding on the elasticity of the ruler, a reporter responds that it is actually important to put the elasticity of ruler into consideration, however they didn't. And us as a reviewer agrees with the opponent that elasticity should also be considered, since it have a pretty great influence on this phenomenon. And the next discussion is regarding the airflows and the geometry of this phenomena, which the reporter answers that the pressure above and below the paper will affect this phenomena. However, if the balance is the differences with pressure differences is gone, then that's the reason for the ball to fall after it. And we consider that the reporter should explain with greater detail other than this.
Okay, thank you. So, reporter, please give your concluding remark.
So they mentioned about something about the opponent mentioned that about the ball's rotate, but my perspective is that if the ball rotates, its friction will only affect vertical, but not. No, it's only horizontal, but not vertical. So I think it don't affect much. And about atmosphere, because I think the only way the atmosphere will affect is that different part of the air has different pressure, and in the other parts it don't work. And just as what we discussed about the impact time is important. And another thing is that I think I agree with the viewer that the theory is very short. And also we should consider more about area and the torque. And I think that's all I have to do.
Okay, thank you. So it's time for jury to raise your questions. Yeah, Professor Tsai.
Could I ask, can the process of the paper being filled with air from around, is it an adiabatic process? That it is, does it follow adiabatic expansion? Adiabatic, without heat input, that it happens quickly. It can have heat exchange, so it's adiabatic.
Do you mean heat?
I mean,
Oh.
I'm afraid you don't understand adiabatic, so I say without heat energy. Heat doesn't have enough time to flow in or out, so this is an adiabatic process.
I think the heat.
Yes, for sure.
Oh, yes, but not very much.
Can that be used to estimate pressure? Can you
I'm sorry, I don't really understand your question.
that is, if I consider the air pocket under the paper as a system,
Yeah.
then during sudden expansion, could I say that it's an adiabatic expansion and then use the equation, adiabatic expansion as the equation, not the ideal gas law, adiabatic expansion, to estimate the pressure.
I don't know what adiabatic.
Yeah, that's the problem.
It means there's no input or output of heat from this air pocket under the paper.
Yeah, she wouldn't understand the adiabatic.
So you mean there are no?
PV gamma equal to constant thing.
You mean there are no heat coming in or coming out?
Right.
Yeah.
Do you
That's
think
the
that
question.
the vacuum?
Do you think that's the process?
Is that the problem?
You think this is
Yeah, I
reasonable?
don't think that's the point.
But you're not aware of that there's a relationship for this kind of process.
No, I'm not. I'm
Right.
not.
You only know PV equals to nRT. You don't know PV gamma can be constant. Okay, sorry. I thought that's an interesting idea. Should be checked. Theoretically, you can use that to estimate the pressure increase because the volume suddenly expand. V gamma is a big factor, so the pressure should drop quickly. You measure it, but I'm given a theoretical estimate. I hope you can come up with the.
I thought it was about PV remains constant.
That's ideal gas law almost.
Oh.
No. The adiabatic is
The temperature
is a
can
process.
can possibly change. Any other question? So I have a short question. Yeah, firstly for reporter. Yeah, you are talking about the duration of a collision is important. Can you tell me why? And also the same question to both the other two presenters. Yes or no, and why?
Because I think it determines the value of the force, and it affects the whole result.
Okay.
You mean the
The duration of collision. How much time it takes?
Yeah, I think that is important because if you put much time on the ruler, there will be more chance for the air to flow in, so it will be easier for the ruler to fall.
How about you?
I think the longer duration of this will cause the balance of the air pressure below and above the paper, which will also cause the ruler to fall.
Okay. So no more question? So we can give score. Okay. Thank you. Okay, so jury are ready. Firstly, the score to the reporter. 57446. Okay. So then the score to the opponent. 77565. Finally, the score to the reviewer. 67665. Okay. So that's the end of this first round of Physics 5. Let's give you, all you guys, a big hand. And, okay, so take a break and have a good